Hey everybody, it's Tracking Pat, and today's video I am going to show you a solution to a problem that plagues people in machining over as long as I can remember. Now I've been running ProtoTRAK since 1990 when we used to make the ProtoTRAK Plus, and of course as we've evolved and everybody else has evolved in the machining, there's still an issue out there that needs a solution, and a lot of times people don't know how to get around it. It's something we call the small step issue. And basically what it means is that you've got to make a movement in your geometry that's smaller than the tool radius that you're trying to cut the part with. So if you look at this part here in my hand, you're going to see that there's a 15,000th step right here. And my tool radius is 31.5 thousandths, therefore it doesn't fit into here. Now I'll explain that part a little bit better in a minute, but I want to explain some of the workarounds and what people do when they run into this. First of all, if I'm using a cycle event in the lathe, right, I could use two cycle events. I could use one that comes to here and straight out and closes off that part, and then another one that does the rest of the part. Therefore, if I make it move far enough away, the tool will fit and there won't be an issue. Okay? But you don't have to do that. I can do the complete part with the tool that has a radius on it. Because the other things that people try to do is they lie and they tell it that there isn't a radius on their tool even though there is. Now if you're cutting all 90-degree corners, that'll work. But if you've got something like this part where I've got radii and an angle, it needs to know the size of that radius in the tool in order to cut the geometry to the correct dimensions. Okay, so what you're going to see here, and I'm going to show you in a minute, is kind of the whole process of what happens. So here, let's go to the control. In the control, I'm already in the lathe. I'm going to push check system, and I'm going to put in my max RPM. And now I'm at the front part of this, and I'm just going to go to program, and I'm going to hit the look button. And you'll see that there's my small step right there on the control. So when I program it, there's no issues. It says, hey, I can do that all day long, right? But what happens is when I change modes and I add in the size of my tool, okay, that's where we start to have a problem. So I'm going to go to tool setup. I'm going to go to tool number 1. I'm just going to go to edit so that you can see that I've put in the radius of my tool right here when I set up that tool. Now I'm going to push return and I'm going to hit tool path. And this is where you get that error, right? It says, cannot apply the tool compensation on event data. Check and edit the event data. It even tells you it's somewhere around event number 3. What it's actually saying is that the tool doesn't fit in what you've programmed. And so the way that you fix that really comes down to just knowing a little bit about math, trigonometry, algebra, okay? What we're really trying to figure out is there's a point here, and I'm going to get out of my own way so hopefully you can see this better. Let's assume this is my tool. My tool's got a radius on it, right? And the problem is I need to be able to know when the tool is still hitting this line, when does it contact that corner? And so what I want my tool to do is just walk right around this. And in order to do that, I need to know where the middle of this tool radius is in comparison to this line and that corner. Now, I'm sure somewhere in math class you learned about the Pythagorean theorem, which is a squared plus b squared equals c squared, okay? If you haven't learned it yet, look it up. Better yet, if you have any of the newer ProtoTRAKs from an S model on up, it's already built into the Math Help, and they call it Math Help Type 28, okay? But here's what we're looking for, right? We've got this problem. I know my tool radius size, and I know the size of this step, but I don't know where this is, right? I know where it is from the line in the x-axis, but I don't know where it is in the z-axis. And what I'm trying to do is I'm trying to cut a line just like this so that both parts of the tool hit the same spot. So if you really look at this, what we've got here is a trig triangle. Okay, hopefully I drew that big enough that you can see it. And in my trig triangle, here's the 3, right? I'm sorry. Here's the C, here's the B, and A is what I don't know. I need to know this dimension. Okay? So let's go back to the control, and let me show you how you do that. I'm first of all going to move back to the program. hit the look button, and I'm going to come forward with list step to where my problem actually is. That Z dimension is -1/2 an inch, and I need to change that. So I'm going to go to Math Help, right? And I'm going to look under polar Cartesians, or if you know what you're doing, you can just say, hey, type 28, because it's always type 28, and there's your trig triangle, right? A is what I'm trying to find out. This is A. So I'm going to come in here, I'm going to come down here, and I'm going to say, what is B? B is the difference between the tool radius and the size of your step, which is 0.0165. C is the actual tool radius, 0.0135315, sorry, a little dyslexic there. And you'll see in here that it's solved, and it tells me A is 0.0268. So right here, 0.0268 is what I need to know so that I can make this 1/2 inch dimension, shorten it by that amount. All right? Now, while I'm in here, if I don't have any other calculator, there is a calculator in here. The newer models are better, but I can still do it this way. 0.5 minus 0.0268 equals 4732 is what I'm looking for. Now that I know that, I can make the TRAK do whatever I want it to do. So I'm going to get back out of here by pushing back. And in here, I'm going to do that and just change this number. So instead of being -1/2, I'm going to say minus 0.4732. What you're going to see happens is that it changed that little step. If I blow this up a little better, you can see it. It changed that step from a straight line to an angled line, okay? And by changing that to an angled line, it's going to allow the tool, when it stops at this line, it's going to say, hey, I'm already there. All I got to do is walk around that and continue machining. So if you go back to the setup mode and look at the tool path, not only do I not get an error, but you'll actually see when I zoom this in that the tool path shows that it walks right around the corner, okay? So by using the Pythagorean theorem, you're actually going to be able to solve your solution no matter what size your step is and no matter what size your tool radius is. Now I'm going to show you another example of this in a minute using a milling machine, which a lot of times can be more difficult because it can never tell it that I'm using a 0 tool radius in the mill, if I'm using tool compensation at least. Okay, so I'm going to show you that, and then when you come back, after I show you that idea, I think you're going to have a much better handle on this, be able to use type 28, solve the solution right away, and get on to whatever you're machining. So I'll see you back here in just a minute. All right, in part 2 of this demonstration, I'm going to show how to do the same thing with a mill part. Now you can tell I blackened this so you can see it a little bit better on the camera, but I have the same type of a situation where I'm actually got a step in here, right, and that step is 1/8 of an inch. But I'm using a 3/8 cutter, okay, so which makes my tool radius, of course, 3/16. All right, so I'm going to explain what happens in the mill, and I've already done all the homework up here on the whiteboard, okay? So my tool radius is, of course, 3/16. My step is 1/8 of an inch, and the difference between the two is a 1/16. So the 1/16 becomes B. C is, of course, the tool radius, and we're looking for A. Now, on the control, I'm going to start out just like I did before. I'm going to show you what the part looks like. Here's that step. That's going to be the problem, right? Going to change modes, go to setup mode, look at my tool table. I've got a 3/8 tool in here that I need to use to cut this, okay? So I go to tool path. I get the exact same error. It means the exact same thing, okay? So how do I fix that? The way I fix it is I go back to my program, and I move to where the problem is, right? So the problem is actually here at this point where I'm trying to move down 2 inches in the x-axis. Okay, what I need to know is how do I stop here and go to that corner so that that tool hits both points at the same time. So I'm going to go back to the Math Help, and I'm going to pull up type 28. All right, I'm going to come down to B. B is 0.0625. C is 0.1875, and it tells me A is 0.1768. Right? If I do it the same way that I did in the lathe video, I'm just going to use the calculator here so you can see what I'm doing, right? I've got 2 inches minus 0.1768 equals, right? So 18232. Hopefully you can see that. So what I'm going to do is I'm going to start here, and instead of ending at 2 inches, I'm going to end at this number, and I'm going to program as if it's a straight line. But in reality, my tool, just like it shows you in the blue, is going to hit both points, and it's going to walk just like that through the part. Okay? So let's go back into my program, come down to where the problem is, which in this case is the X dimension, change that to 1.8232. Okay, when I look, it turns that into an angle. When I change modes and go to the setup mode, into toolpath, you notice it walks right through it, and you can even see step by step. It's going to come into here, walk through the corner, around the corner, and to the end of the part. So this should really help you, like I said earlier with the lathe. This happens every once in a blue moon where you got to use a certain tool, but I have to fit it into an area that it doesn't want to go into. And with a little bit of math, you can walk through it all day long and you'll never have this problem again. Okay? This is a problem that people have had for a long time in lots of different types of machining. I don't know how it works in everybody else's machine, but I know how it works in a TRAK. And so I've been wanting to make this video for a long time, and I was trying to think of the best way that I could explain it to everybody, no matter what their math skills were. And by using type 28 in your math helps, I believe that you can figure it out just by doing what I did here on this film. So I hope this did it for you. I hope it works for you. If it didn't, reach out to me, or better yet, just call your local TRAK rep or distributor and they'll help you with it as well. You'll see me in the next video. Until then, thanks for watching, and as always, keep on tracking. Hey everybody, it's Tracking Pat today here with all the girls from my family, and we want to thank you for watching all of our videos. As always, we know you get a lot out of them, and we really enjoy doing them for you. But today we're actually on our way to the beach. But before we go, we want to remind you that if you haven't subscribed yet, just push the button over here on our left. And if you want to watch the next video, just push the one on the right. Kinley and the rest of them would like you all to remember to give me a big thumbs up. And as always, don't forget to keep on tracking.